Alright, here's a free body diagram problem. It's on an inclined plane. So let's go ahead and get to it. Notice that we have friction in this problem. Two types of friction. Static friction is going to be off of the coefficient 0.6. Kinetic friction is going to use 0.3. We got 38 degrees as our angle. So starting off, we need to draw our free body diagram. And it starts off with gravity. Let's draw gravity pretty large here, just because I know that I'm probably going to need to have it large for later. Normal force is going to go, let's write that in, hold on. Normal force is going to go perpendicular to our surface, so it's going to be angled. Alright, Fn for that. And we probably have friction there, and friction is always going to oppose our motion. It's probably going to want to slide down. Friction is going to want to go the other way. So friction 90 degrees to our normal force, and we're not sure what type of friction it is. I'll just write FFR. So right now we've got our force of gravity, we've got our normal force, and we've got our friction. And so if you look at this normally, we have two vectors that are actually in both x and y, the way that we would usually look at it. And we can actually do it in this case, but since it might be accelerating down and to the right, we probably want to use that as one of our main axes. So this will be one of the main axes, and 90 degrees to that would be our other one. And what this does, it allows us to actually look at our problem like this. And so that's the way we're going to look at it. Here's x, here's y, and we have the force of gravity going off at an angle. The other two are just on those, so we don't need to break them down anymore. The force of gravity for this thing is 30 times 10, and so that's going to be 300 for our hypotenuse to my triangle there. And it has components. And take your ruler and just line it up with that x-axis, move it straight down, and that's going to be a 90-degree angle right there. So 300 is going to be the hypotenuse. 38 degrees is going to be right inside here. And we were able to find these sides now. So let's talk about these sides. This side over here would be the force of gravity in the y direction. This side would be the force of gravity in the x direction. Okay, so the sum of all forces in the x direction, or the sum of all forces in the y direction, probably need to solve for those if we want to solve for our forces overall. In the y direction here, we don't want it to accelerate, so where the sum is going to be 0. And I see that we have two forces, the normal force and the vertical component of gravity. It's kind of weird to say that, but this y component of gravity here, normal force minus the force of gravity in our new y direction, this should be equal to 0. Now, we don't know what normal force is, but whatever it is, it's got to be equal to this force of gravity component in the y direction. This side of the triangle over here, that's the adjacent side. And in the previous videos, I didn't actually write this out, but let me write it out right now. Cosine is going to be adjacent hypotenuse. So this is adjacent side, we're going to use cosine. It's going to be cosine of 38 is equal to the adjacent side, FGY, over the hypotenuse, which is 300. And so in order to solve for my FGY, I want to multiply both sides by 300. So FGY is actually 300 times the cosine of 38 degrees. And so that's what I'm going to put in for my FGY. So normal force minus FGY would be 300 cosine of 38 degrees. Okay, and this all equals 0. And if that's the case, normal force should be the same thing as 300 cosine 38 degrees. And let me get a number for that. 300 cosine 38 degrees, make sure we're in degree mode, 236.4 newtons. Okay, so that's the y direction for you. In the x direction, we have two forces. We have the force of gravity in the x direction minus our force of friction. Now, the force of gravity in the x direction, that's opposite my angle. And if I have opposite and hypotenuse, then that'll be sine. And so just like we did with cosine, it's going to be 300 times the, not cosine, but sine of 38 degrees, minus the force of friction. Now, the force of friction has its own equation, and let's go ahead and write that up here. Friction relies upon normal force times the force, or times the coefficient of friction, mu. Now, right now, which one is it? Is it going to be mu k, or is it going to be mu s? And so, we're going to take a moment, and we're actually going to figure it out. Okay, so normal force times our friction coefficient, and I'll just write it like that. And if I do 300 times the sine of 38, I get 184.7. That's my force of gravity in the x direction. And this is going to be minus friction. And let's see, we don't know if it's going to be accelerating or not, so we can only say that this minus friction, normal force mu, is equal to ma, or 30a. Okay, we're not looking for the acceleration, so we're okay still. Question remains, what kind of friction is it? Is it mu s or mu k? And so if I figured out how much the force of static friction would be with mu s, friction relies upon normal force. Normal force we said to be 236.4. So 236.4 multiplied by mu s, 0.6, 236.4.16, 141.84. 141.84 newtons. For static friction, that's kind of high. But is it high enough? Let's see. There's 184.7 newtons trying to push it down the inclined plane. Static friction can only get up to 141.84. So we actually exceeded static friction, which means we budged it free. We pushed it free, and now it's going to be under kinetic friction. So kinetic friction is this number, times not 0.6, but 0.3 from UK. So 236.4 times 0.3 gives me 70.92, half of what we had before. And that's what we're actually going to use in this equation. So 184.7 minus 70.92 is equal to 30a, and at that point you can solve for a. However, in this problem it just said, hey, what's the value of each force? And so for normal force, we found it to be 236.4 newtons. For the force of gravity, we found it to be 300 newtons. And for the force of friction, this is the important one, it's going to be not 141.84, it's going to be 70.92. And that's because we broke static friction, and we are now under kinetic friction. If the component here, 184.7, if that was less than 141.84, then static friction would be equal to that number, up until the point where it's broken. But here, we only wanted to find our components, or we only wanted to find our forces. There they are, and there is your answer.